Okay, for this question, we'll use a calculator so we can come up with a table of values to find this limit right here. Notice that we have x is approaching 0, so you just remember how to set up a table and choose the x values to help us out with that, right? So here we go. Let me just put on the x right here, and then we have the expression 1 plus x raised to the 1 over x power like this. And I'm just going to give you guys 7 values for x. And I'm just going to emphasize this with you guys right here. If I put 0, and this right here is exactly equal to 0, right? Exact 0 into x, right? When I do that, if you see x being 0 right here, we have 1 over 0, and that's automatically undefined. So that's it. It ruins everything. So when x is exactly equal to 0, you do not have a value for this expression. It's undefined. But we are going to approach it. So let's see if we pick x to be 0.01. And I will approach 0, so let's say 0.001 and then 0.0001. See, this right here is the right-hand side direction, right? So it's the 0 plus. And we can also do the other direction. I will just negate this right here, so negative 0.0001, negative 0.001, and lastly 0.01, but negative in front of that, of course. And of course, you just plug in the values into the x and then just work that out on your calculator. Use a graphing calculator, the quick way I showed you guys. That's pretty much it. So here are the answers. When x is 0.01, we get 2.70481 and so on, so on, so on, right? So I'm just writing down the first 5 digits after the decimal point. And of course, we have a 2 in front of that and all that. All right. Next, we have 2.71692 ... And then when x is 0.0001, we end up with 2.71814 and so on, so on, so on. Okay? Now, if we jump to the other direction, and let me just start with the bottom, because you see, from here, we will be getting closer and closer to 0 from the left-hand side. So if we have that, we will have 2.73199. And then we will have 2.71964. And notice that these values and these two values, they are different, right? Because this is not an even function. So you really have to do the table for both directions. Anyway, for the last one right here, we have 2.71841 and so on, so on, so on. And of course, if you want to get even closer to 0, you can put down 0.000000001 if you would like, right? But I think this right here is good enough. And notice that this value is approximately 2.718 something. 2.718. What does that remind you of? Do we recognize this number? Yes, we should. That's the famous number E. So in fact, the limit of this right here is equal to the famous number E. And that's how you can, just use the table of values to see that. And later on, we'll talk about this without using a calculator. And if you guys would like, you guys can also take a look at the graph of that. So suppose you're graphing y is equal to 1 plus x raised to the 1 over x power. Well, when x is exact 0, we get undefined. So when x is 0, we will have an open circle right here. And why did I put it right here? And where is the y value here? Well, it's E, which is about 2.718. So the picture is going to be this. And again, just use a graphing calculator. I'm not going to show you guys too much. It will look like this right here, right? So this value here is actually E, but when x is exact 0, you do not get E. When x is approaching 0, you end up with E for the limit. Right? So this is the graph, somewhat like that. So that's it for you guys.